Sometimes when we're trying to show triangle congruence, we actually don't want to prove that triangles are congruent. We want to show that maybe two angles are congruent or maybe two sides are congruent. And we want to do that by actually proving the entire triangle is congruent. And then we know, remember, once we prove triangles are congruent, we know that all three corresponding angles are congruent and all three corresponding sides are congruent. So sometimes we want to use something called CPCTC, which stands for corresponding parts of congruent triangles are congruent. And we talked about that right at the very beginning of this when I said we need to show all three sets of angles and all three sets of sides are congruent. So if two triangles are congruent, then all of the corresponding parts of them are automatically congruent. So let's actually do a proof, our example right here, since we have the time. Let's do it right here. So we're going to try to show that side KB is congruent to side AC. So we want to show that KB over here is congruent to side AC over here. We can't directly say, oh, they're the same length. But if we can show that the triangles are congruent, then these are the corresponding sides, and they would have to be congruent. So let's take a look at our given information. We know that angle KBC is congruent to angle ACB. And if I mark that congruent, it's right over here. KBC, right here, that angle is congruent to ACB, that angle. So they're marked congruent. Also, angle K is congruent to angle A, right here. So that's automatic. So we have two angles. I'll go ahead and write angle and angle. Now we probably need to show that the entire triangle is congruent, but how can I do that? So you look, again, we've got a shared side right here. BC is shared, so BC is congruent to itself because of the reflexive property, and I forgot to write given up there. So we have the given information, and now because of the reflexive property, BC is congruent to itself. I'm going to put a congruent mark right there. Now, can we say those triangles are congruent? Which one of our three postulates, we had side, 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 angle, side, angle, side, angle, 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 side, which one of those can we use on these sets of triangles? So you look, and you see angle and a side, not the included side, so it's this one that we're going to be able to use. So now I can say the triangles are congruent. So triangle KBC is congruent to triangle ACB. Why? We have to have a reason, and it's this one, AAS, the angle side theorem. So that's how we can prove that. But now, remember, that's not our proof statement. Our proof statement is this. It's not this, like we've been doing. But now that we know that these two triangles are congruent, all of the corresponding parts are congruent. We could say that angle is congruent to that angle. We could say that side is congruent to that side. And the one we're interested in is that side is congruent to that side. So we're going to write KB. I better raise it up so you can see it. KB is congruent to AC. That's our proof statement. And what's the reason? Well, because the triangles are congruent, we can then say CPCTC. The corresponding parts, all of the corresponding parts of those two congruent triangles have to be congruent. Remember, 6 things are congruent. Once the triangles are congruent, all 6 things are automatically congruent, including that.